Hey guys, so today we are going to talk about, this is lesson 2.3, which is looking at something called a stem plot, which is just another way of graphing numerical or quantitative data. And then we'll also take a quick look at something we call a time series plot, which is just a different type of graph that helps us see things as they change throughout time. So today's objectives, you'll represent and summarize quantitative data with stem plots and time series plots. So let's start with a stem plot. So a stem plot, hold on. There we go. So a stem plot, otherwise known as a stem and leaf plot. We're going to just look at this by creating an example. So these are grades from a test in an AP statistics class from a previous year and a previous teacher. So we've got this list of grades, 80, 97, 83, 86, etc. There are a bunch of different grades, and we maybe want to do some type of graph, but it's something we want to make a graph by hand. We want to do it fairly quickly and not have to pull in a computer program and do all the steps of doing a histogram. So I want to do something that is quick and easy. So one option that I haven't really talked about yet is something called a dot plot. So a dot plot, hello, there we go. So a dot plot shows you have basically a number line just on the bottom, and then you put a dot above each number as it appears in your list. And dot plots are really good for small sets of data, and it's something you can draw fairly quickly on a piece of paper and not have to worry about like categories and intervals and all that stuff that we do with histograms. So dot plots are really good to draw graphs quickly, but again, it works really well for small sets of data that are fairly close together in number originally. So why would we not want to use a dot plot for this set of data with the grades? There are a couple of reasons. One is that we kind of have quite a bit of numbers, and that might take some time, but also the data is really spread out. We're going from in the 50s to the hundreds, so when we look at it on a dot plot, it might be a little bit more spread out than we would want to have it so that we can really understand what's happening. So stem plot is an easy alternative method to display a set of quantitative data that has a broad range of values. And it has the added advantage that you can actually see each individual value. So if you think about a histogram, we don't actually know what the individual numbers in the data are. We just have kind of general ranges. A dot plot, we can see individual values, but again, works really well when our data is closer together. So stem plot kind of does the best of both, right? So we get to see individual values, and it's a little bit better for data that's more spread out. So in this case, students could see how they performed compared to other classmates without just seeing like a list of grades or seeing like what student made what grade. So we're going to create a stem plot or stem and leaf plot. We're going to start by deciding what our stems will be. So usually your stems would be like tens place numbers, but it could be hundreds place or even higher if your data has really wide set values. But usually when we make a stem plot, the stems are the tens places. So our data is going from 50 something to 100. So my stems will be 5, 6, 7, 8, 9, and 10. So again, it's the tens place number. So I have 50s, 60s, 70s, 80s, 90s, and 100s in my list of data. So these will be my stems. Ideally, we should have at least 5 stems. So if we have data that's even more spread out than this, that's when we might want to switch to hundreds as our stems so that we have at least 5 stems. And then we don't have too many stems. So the next thing is, the leaf. So it's the stem and leaf plot. The leaf that goes with the stem will be the digit that's to the right of the stem. So in our case, if our tens place is our stem representing 50s, 60s, 70s, the leaf will be the number that comes out in the ones place, basically. So 52, so 2 would be the leaf. 67, 7 would be the leaf. So for example, right here, the number 80 would have a stem of 8 and a leaf of 0. Okay, so we're going to create first what we call this preliminary stem plot just to begin with by putting each data point into a stem and leaf plot. So again, we already decided our stems would be 5, 6, 7, 8, 9, and 10 to represent 50s, 60s, 70s, 80s, 90s, and 100s. So now what I'm doing is I'm going through my list of data and I'm taking the leaves for each number and putting them in the appropriate row. So 80 I'm going to put a 0 right here next to the 8. So it represents 80. 97, I'm going to put a 7 next to this 9 to represent 97. 83, I'm going to put a 3 here. So I'm just going to stack the 3, the ones place, kind of to the right of each stem. So I'm not writing the 8 again. I already have a stem of 8. The stems are just going to be there once, and the leaves are going to be the tens place of each number. So I go through my list, 86, I'm going to put a 6 on the 8 row, 77, I'm going to put a 7 on the 7 row, and I'm going to keep doing this. 100 would be a 0 on the 10 row. So 10 is the stem, 0 is the leaf. 68, and then there's the rest of them, right? So I just individually, one by one, this is actually not the rest of them. It's like the first 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I think that's the rest of them. But yeah, so we put all of the ones place digits on the right side of the graph. So this is our preliminary stem and leaf plot. This is just getting us started so we know which numbers go or which leaves go into which row. Our last step would be to rearrange the leaves so that they are in ascending order. So I'm going to take all of those numbers right here, and on each row, I'm going to put them in order from least to greatest so that it's a little bit more organized. And this is not a step that we always have to do, to be honest. When we're trying to quickly get an idea of what our data looks like where are the common spots, where are we seeing people answer or have numbers more frequently, we don't always have to put the stems or the leaves in order, but it does add an extra layer of organization. So my next step would be to just put all of the leaves in order from least to greatest. So on that 5 row, right, originally I just had it in order of how they appeared in the list. So it was 8, 8, 5, 9. When I put them in order, 5, 8, 8, 9. So I'm putting them in order from least to greatest on each row, right? And then the other thing we want to do, just kind of make the graph easier to read for someone who wasn't with us when we made it, is we would add a key showing what stem and what a leaf represent. So something like this, I have a key where I have an 8 line 0 represents a quiz score of 80. So I'm explaining what the numbers represent by putting this little key. And then we always want to have some kind of title on a graph. I didn't put that on your notes, but it's a good idea to always put a title on a graph. Another thing to know is if you have an even smaller range, so this is going from 50s to 100s, but if we had a smaller range, maybe we only had quiz scores from like 70 to 90, and that would create like a really kind of small area of our stem plot, and it may not be a very useful graph. One thing we can do with a stem and leaf plot is to do what we call split or duplicate stems. So we would have 2 5 stems, 2 6 stems, 2 7 stems, 2 8 stems, 2 9s, and 2 10s. And then what we would do is, as we're putting numbers in the rows, if the leaf, the ones place number, is a 0 to 4, we put it in the upper stem of that number, of that stem, because there's 2 5s, 2 6, 2 7s. And then if the leaf is a 5 through 9, we put it in the lower stem. And that just kind of splits up the row even further to help us spread out the data more. So if our data is really kind of close together, like if we only had quiz scores from 70s to 90s, and we wanted to spread this graph out a little bit and make it a little bit easier to read and see, we could have 2 rows for 70s, 2 rows for 80s, and 2 rows for 90s, and split it up between upper and lower 90s. Upper and lower 80s, upper and lower 70s. So that's one option we have with the stem and leaf plot to make things a little bit easier to read. Okay, and then the last thing we can do with stem and leaf plot, the way that stem and leaf plots are made, make it really easy for us to compare 2 sets of data by creating what we call a back-to-back stem plot. So let's say this AP statistics teacher, whose grades we just saw, wants to compare the test scores of this class with a stem plot for another class. So this is the second class's stem plot that we put. So to make a back-to-back stem plot, we have one set of stems that is kind of in the middle, so 40s, 50s, 60s, 70s, 80s, 90s, 100s. And then this is the second class, so I can see in that second class there's a 49, another 49, a 51, a 53, etc. There's only one 100, and there were no 90s in that class. So what I can do is add the numbers that we just saw on this stem plot that we created in the last example, and we would put the data on the left side of the graph. It doesn't matter which group of numbers goes on which side. In this case, it makes sense to have first class on the left and second class on the right, but it doesn't really matter. So when I put the numbers on there, let me put them up there, that the leaves are going to kind of go away from the stem. So the smaller numbers are going to be closest to the stem on the right side. And then the biggest numbers are going to be away from the stem on the left side. So it'll look something like this. If we put all of those numbers, we would put them in order from least to greatest, but going away from the stem in the middle so that we have them going up. So that is how that would look. And then I'm really easily able to compare them, and I can see that, like, oh, the second class had lower test grades overall, or quiz grades. We had fewer 100s or fewer grades higher than 89 for that matter. We can compare those two sets of grades a lot easier when they are on this BacktoBack Stemplots. So that is another thing. And again, I still have a key down here explaining what the values mean, and then I would still maybe have a title saying these are AP statistics test grades or quiz grades or whatever they are. So that is stem and leaf plots, and just what we can use them for and all of that stuff. So we're going to move on to the second type of graph we're going to look at today, which is called a time series graph or a time series plot. So a time series graph, as you probably can imagine, is helpful in looking at behavior of a measured variable over time. Makes sense. It's a time series graph. So the horizontal scale of a time series, so the x-axis, is used for time, so either years or months or maybe even time of day, or an amount of time since the beginning of the experiment, something like that. And then the vertical scale, or the y-axis, is used for the variable that we're measuring, so the numerical variable that we're counting or measuring. So I'm going to show you a couple of examples of time series plots that I pulled from the interwebs. So this one is an example where it's showing the year from 1900 to 2009 on the bottom on the x-axis, and then we have the price of gold per ounce, dollars per ounce, throughout all those times. So we have a point or a dot for every year from 1990 to 2009, and we can kind of see how the price of gold stayed really, really similar, maybe increased a tiny bit, and then once we hit like the 60s, 70s, it started jumping up in price. So we can kind of see how the price of gold changes over time. And then here's one that I found where it's showing 5 different time plots on the same graph, so we can compare the trends and the patterns. So it's years from 2013 to 2019, and it's the percent of internet users who use these specific internet platform or social media platforms. So Facebook, you can kind of see it started in the 80%, and then it started to drop and people don't use it as much. And then things like Instagram was like basically nothing, and then all of a sudden now it's pretty high, etc. So we can kind of see how things change through time in comparison to each other. So those are some time graphs. So now we're going to make a time graph really quickly. It's basically just like making like graphing points on a line. So these are Mrs. Overman, who is a statistics teacher at Cedar Ridge. Her total number of steps recorded on a Fitbit in 2017. So we have from January to December in 2017. These are a lot of steps, the entire total amount of steps for the month, for each month. So what we're going to do is make this time series graph. I'm going to start by putting my months along the bottom, because remember, time always goes on the x-axis. So I'm just titling January, February, March, April, May, all the way through December. If you're doing these notes on the computer, I did put little boxes for you to type in each month on the bottom. And then you can put month as the title of the x-axis. Okay, now I'm going to do the y-axis. So I'm going to go ahead and just put numbers in thousands of steps. Instead of trying to deal with all these numbers, I'm just going to say, like, I'm going to make my x-axis go up to that. So 200,000, 400,000, 600,000, 800,000, 1,000,000, which is a million. in case you were wondering. So I have my thousands of steps on the y-axis, and at this point, I'm just going to be putting points. At this point, I'm putting points on the graph for each month, and I'm just going to do this as best I can. It doesn't have to be perfect, but I want to at least do my best. If you were doing the notes on the computer, I have 12 dots up here at the top that you can move around to the appropriate spots. So I'm putting dots. So January was 271,559. So I'm going to estimate that happens around there-ish. February is a little bit less than that. So I'm going to put a dot around the same place. March is a little bit less than that. So again, I'm putting a dot in that same general place. April, 274, a little bit higher again. May, we jumped to 331, so definitely higher. June, we jumped to 610,676, which is way up here. There's July, way up at 900,000 and 908,000. August is back down to 235. September, there's October, November, and December. And then just to make it a really nice looking line or time series graph, I'm going to connect each of these points with a little line like so that they're connected and I can see the pattern between each month. So once we've graphed it, we can maybe answer some questions about what are the patterns that we see. So for example, on your notes, it says that normally Mrs. Overman totals about, we'll say around 250,000 steps, maybe 240,000. That's kind of the general pattern, maybe a little less or a little bit more, but usually her steps are in about that range every month. And then the question is, do you notice anything unusual over the graph? So most of the time she's averaging or totaling about 250,000 per month. But what is unusual, right? So the unusual thing, I don't think I have this on here typed, but we can kind of see that starting in May through like July in those summer months, she's all of a sudden walking a lot more and getting a lot more steps in. So those numbers jump in the summer and then go back down when we get into the fall again. So those are patterns that we see. And that's really what you'd be expected to talk about on a time series graph, is just what are the patterns that you see throughout the graph. So that is it for today in terms of different graphs. And yeah, I hope you guys learned a lot. If you have any questions, let your teacher know.